Hi, my name is Junho Kim from Seoul National University. In this video, I'll present our paper titled Fully Geometric Panoramic Localization. The goal of panoramic localization is to find the 6DOF pose of a query 360-degree image with respect to a pre-captured 3D map. Conventional localization systems leverage visual descriptors from the image and point cloud, which attains high performance but incurs large storage costs and privacy concerns. In this paper, we present an alternative direction with a localization pipeline that operates solely using the geometry of lines. By exploiting lines, our method attains a small map size, can mitigate privacy concerns, and remain robust against lighting changes. Our method operates through a three-step process of input preparation, pose search, and refinement. From the input lines, our method first obtains the principal directions. Then, by pairing together lines with different principal directions, we extract three groups of line intersections. As the next step, our method performs coarse pose search by comparing distance functions in 2D and 3D. To elaborate, 2D point distance functions are defined for arbitrary points on the sphere as the distance to the nearest line intersection. Similarly, 2D line distance functions are defined as the distance to the nearest line segment. Based upon the 2D definitions, 3D distance functions are extracted for a pool of poses within the map. Specifically, at each pose, we project the 3D lines and their intersections onto the sphere and compute the distance function values. Using the line and point distance functions, we perform pose search by comparing the distance function values for poses in the pool. To enhance pose search accuracy, we make multiple distance functions for points and lines clustered using the principal directions. Our method then selects the top k poses with the smallest distance function discrepancy, which are used for refinement. The last step, pose refinement, initiates by projecting 2D, 3D lines on the sphere. We then establish line intersection matches from nearest neighbor association. To prevent outliers, we allow matching only for intersections coming from the same set of line direction types. Under such conditions, each intersection match leads to 2 line direction matches. Subsequently, we perform pose refinement by minimizing the discrepancies between the matched line intersections and directions. Here's how the minimization process leads to refined pose estimates. We show the intersection matches in orange. Here's another example. By exploiting the sparse matches of lines and their directional regularities, our method can quickly and accurately refine the initial poses. To further scale our pipeline for large-scale scenes, we propose 2 acceleration schemes for distance function comparison. First, we suggest caching the 3D distance functions prior to localization such that they don't need to be computed on the fly. Note, however, that naively caching the function values for all combinations of translations and rotations can become memory intensive. Therefore, we only cache 3D distance functions for translation variations under the identity rotation and account for rotation variations by warping the 2D distance functions. Now the distance functions can be quickly compared for large-scale scenes. Our fully geometric pipeline performs fast and accurate localization compared to conventional visual descriptor-based methods. The table on the left summarizes the localization accuracy and runtime measured at 4 large-scale indoor scenes, where an exemplary sample is shown on the right. The accuracy of our method is comparable to the baselines that exploit learned visual descriptors. Further, our method can quickly perform pose search or refinement and maintain a small map size due to the effective exploitation of sparse lines and their intersections. In conclusion, we propose a novel localization pipeline solely based on the geometry of lines. Our method aligns the spatial distribution of lines and their intersections for pose search and refinement. Experiments verify that our method can perform accurate and efficient localization in various challenging scenarios. Thanks for listening.